In this lesson, we're going to solve systems of equations using the elimination method. We sometimes call it the addition method, and you'll see why in a second. So if you look at the following equation, normally we would add 3 to both sides and then divide by 2 to solve this. But consider this. What if I wrote another equation, 3 equals 3, and I added the left sides of the equations and the right sides of the equations? I'd get 2x equals 10, which means x is 5. The question is, can I do this? Well, the answer is yes, because if you look at this equation here, really all we're doing is adding 3 to both sides of the equation. It's just another way to represent that. So we're going to use this idea of adding the left sides and the right sides of equations in order to solve systems. So let's go ahead and look at this first problem. Notice if I add the equations, I get 3x equals 6, which means x is 2. So 2 is the x value of our solution. So now I'm going to use the first equation, and I'm going to plug in the 2 for x, and now I can find y. So we get 7. Now if you look at the first equation, I'm going to go ahead and check my answer here. Notice that 2 plus 7 does equal 9. And if we look at the second equation and we plug in 2 for x and 7 for y, we get 4 minus 7 equals negative 3, which is also true. So you can see this is a solution. Let's look at number 2. This time when we add the equations together, x is eliminated, and we get 9y equals 27, which means y is equal to 3. And so now we can use one of the equations. Let's use the first one. We know that y is 3. So if we solve this equation for x, we get x equals 4. And so our solution is 0.43. And I would just remind you to check your answers. Very easy to do that on the calculator in just a minute or less. You can also do it in your head. Number 3. Now this time, notice if I add the equations together, I get 4x plus 3y equals 11. The only problem is I didn't eliminate x or y. So even though this equation is a valid equation, it doesn't help us at all. So let's not do that. Now what we can do is look at the x term in the first equation, the 3x. It'd be really nice if our other term were a minus 3x. Well, we just can't change that to a minus 3x. But what I can do is I can multiply the whole equation by negative 3. And so this is how we're going to write our work. We're just going to rewrite the first equation. We're going to multiply the second equation by negative 3. By doing that, we get opposites for x, which is what we need. So when we add these equations together, x is eliminated. Now, there's no one way to do this. I could have eliminated y instead by multiplying the first equation by negative 2 and then adding the equations together. So there's always going to be more than one way to do these. We're just going to look for the easiest way. So here we see that y is 1. And if we go back and plug in 1 for y, I'm going to use the second equation here. You can see that x is going to equal 2. And so that's the solution for that one. Let's move on to number 4. Now notice with the 3x and the 5x, I can't really multiply the 3x times something to get a negative 5x, because again, I'm trying to create opposites. But if you look at the y's, notice it would be really nice if I could make that 2y into an 8y, because then I would have opposites. Well, we're just going to go ahead and just rewrite the first equation. We'll multiply the second equation by 4. So notice by doing that, we do get opposites for y. So now when we add the equations together, we get 23x equals negative 46, which means x is negative 2. So again, we have half of our answer. Let's use the first equation to find the y value. So if we plug in negative 2 for x, and we solve this equation for y, we end up getting y equals negative 1. Alright, let's move on to the next one. Now, this time, if you look at these equations, there's really nothing I can do to one of the equations so that I create opposites for x or y. So in this case, I'm going to have to multiply both equations by something. So I'm going to just go ahead and eliminate x. I could have chosen to eliminate y. But notice, if you multiply 3 times 4, you get 12x. So I'd like to work with 12x. I want to have one of my equations to have a 12x and the other one to have a minus 12x. So let's see. Let's go ahead and multiply the first equation by negative 3. And so we get a minus 12x, which means we need to multiply the second equation by 4. And now we'll have a positive 12x. Now keep in mind, we got to multiply all the terms here by 4, and that's how we get the new equation. You want to make sure you multiply all of your terms by whatever number you've chosen. Alright, so now let's go ahead and solve this. Notice we eliminate x, and we are going to get y equals negative 5. Let's go back and use the first equation. We know that y is negative 5. So let's go ahead and solve this equation for x. We get x equals 4. And so our solution is the point 4, negative 5. Again, I would encourage you to check your answers. Let's move on to number 6. Now you can see this time we're going to have to multiply both of the equations by something again. In fact, I think I'm going to work with the y this time and try to eliminate y. I kind of like that idea here because we have opposites as far as signs are concerned. So what I want is, that means I can multiply both of these equations by a positive number, which is kind of nice. So let's multiply one of the equations by 3 and the other one by 5. And then we'll have opposites for y, and we can eliminate y. So we're just going to multiply the first one by 3, multiply the second equation by 5. So notice we do have opposites for y. So when we add these together, we get 31x is equal to 124. We're going to get x equals 4. Let's go ahead and use the first equation. We know that x is 4. So let's go ahead and solve this equation. We get y equals negative 1. Let's go ahead and move on to the next equation. It looks like in this situation we can multiply the first equation by negative 2, and that way we'll get opposites for x. So let's go ahead and do that. Keep in mind, we're always trying to find the easiest way we can do this. Whoops, so that got ahead of me there. Alright, so here, when we do that, we're going to get 0 equals 0. Now, when everything falls out like this, that's an indication that these are the same line. In fact, if you multiply the first equation by 2, it will be the same as the second equation. So they're the same equation, and this is the case where if you were to graph these, you have the same line. So our solution is infinitely many solutions. Let's move to our last example. Whoops. Oh, let's see, I'm going too fast here. So in this problem, we can multiply the second equation by negative 2. Let's go ahead and do that. first equation we just rewrote. So let's go ahead and add those together. Notice what happens this time. Our variables fall out. We get 0 equals 9, which is a false statement. And that means anytime you have an equation you're trying to solve and you get a false statement, that means there's no solution. And so that's going to be our answer. And that's it for this lesson.